So today we'll be talking all about Kaggle journeys, and I'm going to start by telling you about my own journey in a little presentation. And then in the second part of this data hour, we're going to go fully interactive, and we're going to go onto Kaggle and explore the platform. And you can ask your questions, and I'll try to answer them based on the things that you're interested in for your own Kaggle journey. All right, but let's start by telling you a story. 5 years ago, I decided to finally learn more about two exciting frameworks that I kept hearing about everywhere. And the first, for me, was the R tidyverse via the fantastic book R for Data Science. And this is a much recommended book, regardless of your language preference. And the second one was the Kaggle Machine Learning and Data Science platform. And little did I know that the combination of those frameworks would transform my career and open up a whole new world of exciting challenges. And like for our Dragon Ball friends here, that fusion really increased my power level. So today, I would like to show you how the Kaggle community can help you to learn, grow, and to inspire others. And whether you're a regular in Kaggle, have only ever tipped your toes into the community, or have never heard of it at all, I hope that my story will inspire you to make the most of the amazing opportunities that the community provides and to share your fantastic ideas and creativity with the rest of us. So that sounds great, you might say. I only have a very small question. What exactly is Kaggle? Well, I'm glad you asked. Kaggle.com was launched 13 years ago already as a platform for machine learning competitions. And the challenge here is to build competitive predictive models for supervised machine learning problems, with the best solutions scoring highest on an objective leaderboard. And while competitions remain one of the main cornerstones, today Kaggle covers many key aspects of the data science landscape. Users can upload and curate their own datasets. Lively discussion forums host many conversations about machine learning and data science and everything around it. And Kagglers can run, publish, and share their own notebooks directly on the site. So there's so much to explore and to discover here, but I can also see how all these possibilities can be a little bit confusing, right? Or maybe even intimidating when you're first joining the community. And I get it, I really do. Myself, I felt apprehensive at first as well, when I was seeing all those smart people and their clever ideas. So much so, in fact, that I decided to join anonymously under the pseudonym Heads or Tails. Nobody knew who I really was, which really helped to alleviate much of the pressure I would have otherwise put myself under when it comes to actively participating in the community. So with this little trick, I felt free to do my regular work during the day and to be on Kaggle on the evenings and, well, many nights as well. And I quickly discovered that the Kaggle community was exceptionally welcoming and supportive to everyone, and it remains so to this day. The other trick that helped me was at first to focus on only one aspect of Kaggle, instead of trying to do everything all at once. And in my case, I gravitated towards the notebooks. You see, I was always a fan of data visualizations, and my academic background had trained me to write coherent reports. So my main goal was to learn new tools and new methods, and I always learn most efficiently when I can apply these new tools on a practical problem. Therefore, it was natural for me to write and publish notebooks so that I could learn and I could share what I learned with others. So today, my presentation slides from my own story will focus a lot on the notebooks, but much of what I'm telling you can be translated to Kaggle's other aspects, like competitions or data sets, or also courses, which might be a better fit for you and your own goals. And we're looking at all of them in the interactive part later. And also, all of these areas are representative of Kaggle as a whole, and in turn, they also contain smaller categories that are representative of them. So in a sense, this is a fractal approach and a fractal talk, in which I would like to show you that I can be less than just a one-dimensional speaker. So I started learning more about data science and machine learning and to write Kaggle notebooks to practice what I had learned. And at the same time, I started reading the notebooks that other people were writing, like people like these Kaggle Grandmasters here and many, many others. And it really exploded my horizons. There was so much to learn. To give you an example, I remember when I first discovered this notebook here, written in R by Jonathan on US flight tracking. I had never worked with geospatial data before, and his map visuals, they just blew my mind. The way he presented his insights was so clean and well thought out. There's a lot of information here in this map, but the design choices make the map accessible and easy to digest. So I really wanted to learn how to analyze geospatial data. And then this competition launched, which was about predicting taxi trip durations in New York City. But it was really about writing notebooks that others would find helpful, describing the data, breaking it down, finding the hidden insights. And I started to take my exploratory approach and to learn from scratch about maps and geocoordinates and everything. So this here is my very first interactive leaflet map from the notebook that I wrote. And I'm still using leaflet today based on what I learned from this experience. So in this slide, of course, it's not interactive because it's just a picture, but leaflet is a nice tool that allows you to zoom in, zoom out, have certain markers that show certain things. It's great for spatial exploratory analysis. And even better, my notebook ended up receiving the most community votes in this competition and winning me a prize. And when that happened, I really was over the moon and I had found my new passion. So in the following months, I jumped into almost every new competition that was launched so that I could learn about the specific tools needed to understand the data. And my goal was to be the first person to write a comprehensive notebook on exploratory data analysis of the competition so that other competitors could get a jump start when they joined. So EDA became my focus, and it allowed me to discover and share a lot of cool stuff. So for instance, I joined a time series forecasting competition so that I could learn about methods like ARIMA and tools like Profit. And the target here, in this case, was to predict web traffic for certain international Wikipedia pages. So in this example plot, we can see that the views for the wiki page of the band 21 Pilots, they started to increase massively in early 2016, right? Especially for the non-English pages here. So English is this one, those are the non-English pages. And there's some very interesting lag effects here when it comes to this increase, right? Which happens in these countries earlier and in these countries later. And also the lags between the different spikes that are happening here. So you would try to understand what causes them and which aspects might be country specific and how all these things relate to one another and how these different wiki pages might feed into one another. And aspects like this made the competition interesting and challenging as well, which is, a synonym for interesting. I also participated in my first NLP competitions, natural language processing. In this particular example, I flexed my storytelling muscles and I wrote my own chilling short story around the analysis of language used by classic horror writers like Shelley or Lovecraft. And here in this example, you can see that love and death are kind of at the center of most of these stories, intertwined in an eternal battle for the human soul. So with every new competition and every notebook, I was learning something new. New software tools, new packages, new visualization strategies, and many new ideas from reading other people's notebooks and exchanging thoughts with them. And one of the great things about Kaggle notebooks is that you can fork and tweak them directly on the platform by using this little button here. And this happens very often with competition modeling code, when people build on and extend each other's ideas. And the Kaggle community is very good at learning from one another and standing on each other's shoulders to see further than we otherwise could. And my own journey benefited a lot from the support of the Kaggle community, which made me the first Notebooks Grandmaster. At the time, it was called Notebooks Grandmaster, a title which you can earn through community votes on your notebooks. And through your Kaggle profile, you can then showcase your work and your achievements to the world, for instance, to recruiters. So my own profile summarizes my top notebooks and other achievements in a compact way. And I'm pretty positive that it helped me in my career change from the ivory towers of academia to doing data science in the real world, in industry. And during my various interviews for jobs, the lessons that I had learned on Kaggle, they were invaluable. And I'm sure the whole Grandmaster thing didn't hurt either. So one thing that I'd like you to consider is that I think that the use of Kaggle as a portfolio remains pretty underrated, even today. It is really a great way to present and communicate your work, especially your notebooks. And I would like to encourage you to make your Kaggle notebooks public so that others can learn from them and give you feedback. And I've read a lot of notebooks over the last 5 years, and virtually all of them had something new and interesting that I could learn. And I really appreciate that the authors of those notebooks made them public so that I could learn from them. So in fact, 2 years ago, I've started an initiative around notebooks. So let me tell you about my initiative. Well, no, it's not that one. Nope, that's not the one either. I think I'm really dating myself with that reference though. So if you recognize it, let me know. It makes me feel less old. Now, what I'm talking about is an initiative to discover and to highlight well-written Kaggle notebooks, which for whatever reason hadn't received the attention that they deserve. And I'm calling them hidden gems. And after reading hundreds of notebooks and designing quite a few myself, I would like to share with you what Kaggle taught me on how to write a great notebook. So here are a few tips that are illustrated by different hidden gems and their authors. So the first thing you want to do is, of course, to introduce your work, because you want to capture the attention of your readers and draw them into the analysis. So some topical images or illustrations, they often go very well with a few introductory paragraphs that explain the goals and set up the stage for what's to follow. So like Laura here, you can use a picture of cocoa beans to lead into your analysis of chocolate taste ratings. Right? You can add a little bit of context, what this data set or what this competition is about, where the data comes from, and what the motivation is for this notebook and the goal of the competition, for instance, or the specific interesting aspect of the data set that you're focusing on here. And explaining your methodology when it comes to conducting your analysis will help the reader to follow your analysis through its various steps. And this can be a part of your introduction, for instance. And you can even go as far as Shankar here did and create a flowchart of pictograms that outlines your approach, right? So he takes us right through understanding the domain, then the story flow, the data preparation, right? Data cleaning, data wrangling is always crucial for any problem, data visualization to communicate, and then how you structure these insights into your report, right? So something like this is really some next level methodology communication right here. And it allows you, to see at one glance, what is this notebook all about? What is this analysis all about? And what is the story all about? And great visuals are, of course, at the heart of most notebooks. And whether it's for exploration or for communication or for both, you really want your plots to be clear and accessible. And that can mean simple plots, or it can also mean plots that are complex but well designed, like in this example here. So this is a visual by Daniel on climate models and the rising CO2 levels over time. And as a former academic, I can tell you that a plot like this would not look out of place in a journal like Science or Nature that are really high profile, or on some high profile website, right? So this plot is meticulously crafted. It has insets, it has annotations, and it definitely needs a little time to digest, but you have everything you need in one place here. Right? You can look at you can look at the overall trend, you can look at the models that follow the specific data points. And like with all of these notebooks that I'm showing you here, if you want to learn more about them, about the visuals, about the general approach, definitely go and check out the notebook on Kaggle. So visuals themselves are not enough though, right? You can show something, but you also want to add your interpretation, because in this way you can make sure that you document your findings, and not just for your audience who's going to read your notebooks, but also for yourself. So if you come back to your work, maybe 6 months or a year from now, you will really be grateful to, the past version of yourself for writing down all the thoughts on what made this plot so interesting, right? And Parul here in her notebook demonstrates this very well with her points to note, complete with a little pictogram here as a visual anchor. And documentation is, of course, also the cousin of narration. And it really helps to write down your thoughts and ideas in a coherent form, and to lead the reader through the flow of your analysis, right? A well-structured notebook will have a certain narrative that it follows. And the better you narrate this journey for your reader, the easier it will be for them to ingest and access your findings, right? The same is true for any presentation that you give. You want there to be a narrative thread that your audience can follow, and that allows them to truly understand what you're talking about and why the thing that you're talking about is so important. And the final tip is that your notebook and your visuals specifically can go beyond the exploration of data into the explanation of models. So in one of the most outstanding hidden gems that I've seen, Jack here was charting the journey of an image through a neural network, which is an excellent title, by the way. Right? Titles are important too. But what I want you to focus on here is how he uses the power of data visualization to show how different layers of a very simple convolutional neural network, but nonetheless, transform this handwritten digit here, right? It's the famous MNIST data set, all the way through to the classification layer, right? So if you're a beginner if you're a beginner to neural networks, if you're encountering them for the first time, or if you really just want to read something really cool, even if you already know about neural networks, then definitely check out this notebook, right? It even includes some dimensionality reduction and projection, where he puts the different digits into different parts of an embedding space. It's really well done, and it gives a prime example of how something as complex as a neural network, right? Which, if you're not a data scientist or machine learning engineer or practitioner, if you're talking to somebody at your work, for instance, who works in, I don't know, sales or so, then a neural network will be pretty difficult for them to understand. But through visualizations like this, you can communicate even something complex by showing the impact that it has on the data and on the results. So with all this inspiration, you might be asking how to start, how to begin, how can I write my own stuff? How can I start learning? How can I start my journey that will lead me on a similar path to building something amazing like these people did? And well, there are many paths, but to give you a specific starting point, I've put together a Kaggle dataset that is regularly updated and that contains a lot of interesting features that you can use to build your first notebook, right? So this is a data set on US natural disaster declarations. And well, it is, it is focused on the United States, but it contains features that are geospatial, right? Which can allow you to make your first experiments with maps. It contains time features, when a certain disaster started and when it ended. And we're talking about natural disasters here, like hurricanes, for instance, which the US experiences quite frequently around Florida, for instance. We're talking about earthquakes, we're talking about floods and wildfires and things like this. And they happen at certain times and they end at certain times. And this agency is responsible for declaring a disaster so that the government can provide help to the people affected by it, right? So there's a lot of different features here that make this data set particularly interesting for trying out different analysis methods that focus on geography, that focus on time, that focus on features like this, right? And what I'd like to invite you to do is to use this handy button here to open up a new notebook after you went to the data set. And this will get you to an editor and you can explore the data right there on the Kaggle platform. So I invite you today to go to the datasets page and start your own Kaggle journey right now, right today. Or, maybe tomorrow, since it's already the end of the day in most of your time zones. It's still the morning for me. So now we begin the interactive part, and we're going to take a tour, and I'm going to be your tour guide through the Kaggle platform, through its various aspects, and we're going to talk about what opportunities Kaggle provides and, how you can get started in this very large platform, which has grown over more than a decade and has many, many aspects that are interesting and relevant for data science and machine learning. All right, so I'm gonna stop the slideshow and gonna go to Kaggle. This is my profile. If you have any questions, I might be able to see them, but if I open them in a slide share, there's going to be lots of black bars in the way or in the screen share. So maybe the moderators can accumulate the questions and ask the questions as we go along. Sounds good? Let's do it. All right, so your Kaggle profile is the starting point of everything, right? Here's where this is what I showed you before. Here is where you kind of accumulate your competitions, your data sets, your notebooks, and discussions that you're participated in. And there's a poll, apparently, that you can participate in this session. So let's start with the competitions. So competitions were the first thing that Kaggle did, and it's still one of the main focal points of the platform. And there's a lot of competitions that are happening at a specific time. Some of them are analytics competitions, like this one here. So there's a yearly survey that Kaggle conducts among the community. And true to form, the Kaggle team then aggregates all the survey responses and makes them available to everybody. And then you can write notebooks and build notebooks to explore this. So here, the evaluation is based on all these kind of notebooks criteria that I talked about earlier, right? Composition, is there a narrative thread, originality, documentation. So this is a competition where you don't work on a machine learning problem, but you work on building a notebook that can communicate interesting aspects. And there are prizes, right? You can win money and you can win recognition through these competitions as well. But most competitions are machine learning competitions where you are tasked to predict, and the predictions will end up on a leaderboard. So let's take a random competition. This one here is about detecting gravitational waves, okay? And the competition page usually starts with a description of the problem. here it's a very kind of specific problem that gravitational scientists have about detecting faint signals, and especially long-lasting gravitational wave signals here in this case, in data that can be very, very noisy. Because these detectors that have kind of just come online a couple of years ago, they are able to detect gravitational waves for the first time, but they have to be super sensitive in order to do this. And, there's lots of noise from all sorts of things that are happening on the planet that creates signals that, might be mistaken for gravitational waves, right? So each competition comes with its own data, of course, and you can explore the data sets and kind of learn more about them, right? So there's kind of train and test folders that contain images here, and there's the labels, and then there's a sample submission that shows you what shape your submission should take. And I haven't joined this competition, so I can't share with you, and you need to agree to the competition rules anyway to see the data. And then there's a leaderboard that is the evaluation of your solutions, really. So this is how the winners are determined, and this is how the people who will get money are determined, right? So this green means here you earned money, and then what kind of medal, competition medal, will you get for finishing here. So here we have about 600 people that joined, and you can build your own model, you can submit it to the leaderboard, and you will get feedback immediately as to where your solution is placed in the context of all the other competitors. And each competition also has its own discussion forum where you can ask questions that are very specific to this competition, right? So here it really goes into the details of, there was a competition, similar competition last year. What is the difference? This one really noise and Fourier transformation. So people are talking about specific aspects of the competition here that can help them to understand, and that can help them to share their ideas with others so that they can learn as well. And the discussion is one way in which they're doing that. And then the other way is, of course, the notebooks that I talked about. So if you sort by most votes, you get the most interesting notebooks in a specific competition, or the most highly upvoted, because not every time a notebook gets the recognition that it deserves, which was the reason for my hidden gems in the first place. And here you can see that. And if you're joining a competition for the first time, then you want to start with these kind of explorations, with these EDAs, with these baseline models, in order to better see what's going on and to get you a head start, right? And if this is your kind of very first time on Kaggle, then there are specific competitions that are designed for getting started and for becoming familiar with the Kaggle environment. And the classical ones are Titanic. This is almost always the competition that most new people are doing on Kaggle. And it is about predicting who survived the Titanic and who did the Titanic disaster, which of course, has seen many movies and books and, Hollywood related endeavors, and who didn't. And it's a classification problem. It's a binary classification problem. Either you survived or you didn't. And it has tabular data that you're working with. Right? And you have features like sex, male or female, the age, what kind of ticket they had, what kind of fare they paid, and other features as well that you're working on. So Titanic is kind of a classical getting started competition. And the goal of these competitions is not so much the leaderboard, because the leaderboard is a rolling one and there are no prizes. It's more about getting familiar with the Kaggle platform and how everything works, how the notebooks work, how the submission works, how the discussion forums work. And then you can kind of keep an eye on the active competitions, the actual kind of prize money competitions that give you dollars and that give you ranks and medals as well. And you can see whether something comes up that interests you, right? So if you're particularly interested in recommender systems, then you want to say, oh, I want to join this competition. This looks very interesting to me. And competitions usually run for 3 months, which is plenty of time to get acquainted with a new problem. And everybody kind of starts from scratch when a new competition launches, because nobody has really seen that particular data set before. And people can kind of build on their previous experiences and previous competitions that they were kind of taking part in. And that can give them an advantage. But you can catch up on this advantage pretty quickly through the notebooks that everybody is publishing. So usually, in the first few weeks, you kind of learn about it and you build your baseline model. And then, there's a lot of time for you to tweak that, to try to improve that. And then the last few weeks of a competition usually get a little bit more frantic, depending on where you are on the leaderboard, and you're trying to put more time in or more work in. But the 3 months are almost always enough to really jump into a very new problem that you haven't even heard of before. This is a brief overview of the competitions. Now, do we have any questions? Do we have any questions on the competitions, or do we have any questions in general? Which book? The Kaggle book? Or I think the Kaggle book is beginner friendly. If you mean a different book, let me know. How to learn data analysis using Kaggle? What I just said, just get started, jump into it. Will you talk about game development? I will not talk about game development. Which aspects of game development would be relevant for data science and machine learning? You can, and another poll. You can maybe ask a different question. Can we import data sets from outside? Yes, we can definitely import data sets from outside in general. So data sets is one aspect of Kaggle that I'm going to talk about in a little bit after the competitions, but you can upload your own data sets onto Kaggle, right? So here's some of mine. Kaggle is not mine, but it's a very kind of popular data set. And you can upload, you can curate your data sets on Kaggle, and some competitions, not all of them, allow you to bring in external data sets, as long as you share with the rest of the participants what these data sets are, so that nobody has kind of some secret data that they can benefit from. And that doesn't always, it doesn't always make sense for specific competitions, and it doesn't always work. But for some of them, you can do that. All right, now I lost okay, this is very specific. May you elaborate upon debiasing confounding factors, such as how Fitts law experiments can lead to false conclusions, all with the Kaggle notebook? Well, to answer in general, you can do anything you want in a Kaggle notebook. And you can look at biases, you can look at systematics, you can study whether the setup of a competition makes sense within the context of the competition. You can definitely do that. Now that there are other platforms like Git, Discord channels, how does Kaggle fit into the current environment? Well, GitHub has been around for a long time, and GitHub can be a good place to share your portfolio as well, like if you're a practitioner, for instance. And Discord can be good for chatting about specific things, right? There is most of the communities, like Hugging Face, for instance, they have their own Discord, or Fast AI, they have their own Discord where you can kind of talk about these specific things. Kaggle is really good when it comes to solving a specific problem together, right? Those are the competitions. So for 3 months, you're really focused on a very specific data set, a very specific problem, and all the different ways in which this problem can be solved. And because people on Kaggle come from so many different backgrounds, there can be many, many ways in which a problem can be solved. So this is something that I guess you could try to do something artificially like that on Discord, but then on Discord you would only have the discussion part, and on GitHub you would only have the code sharing part, whereas on Kaggle everything is together, right? You have the notebooks, you have the discussions at the same place, and you have everything there, so that you can learn from a great many more people then you could get to participate in a Discord channel audit. You could get to use a certain GitHub repo, for instance. So it's this part, it's the kind of the community aspect, the learning aspect is much more streamlined. And then through the data sets that you can publish and through the notebooks that you can publish and through the discussions that you can publish, there's also much more engagement for yourself that that you can get. You can get feedback. You can have you have everything that you need for machine learning and data science in the same place. Somebody asked about the difference between data analytics and data science. This is difficult because this is kind of sort of a more of a recruiting or hiring question, and a lot of places that advertise for data science probably need a data analyst, and maybe even vice versa. The way that I see it is that data analysts are primarily working on data cleaning, data aggregation, and some simple modeling, right? Whereas data scientists can work on more complex machine learning problems as well. So I wouldn't necessarily expect a data analyst to know how to write a PyTorch training loop, for instance, but I would expect a data scientist to know that. That's my personal answer. But there's a lot of vagueness with these terms, especially when you're kind of looking at job openings or something like this, because all these fields are still relatively new, and people don't always have a clear idea what it is that they need and they want. So you always want to look at specific requirements if this is the context of your question. All right, what specific knowledge, masters, probability have you found along your journey when going through some of the notebooks you checked? And what has been your strategy to deal with knowledge gaps? The specific knowledge is vast. So when I first joined Kaggle, I had some experience in data analysis and data wrangling, and I had done some simple machine learning, so up to random forests, for instance, but I hadn't really encountered tools like booster trees, and I hadn't really done anything with neural networks. And a lot of what I know today, I know from Kaggle notebooks, and that includes some statistical techniques as well. That includes some, you can find probability techniques like Bayesian things on Kaggle. It's kind of, in a way, it's more geared towards machine learning than statistics, but there's still a lot of statistics knowledge out there. And like I said in my presentation, so the geospatial analysis is something that I didn't really know before. The time series was something that I had done before, but I hadn't used methods like ARIMA, for instance, because I wasn't really interested in predicting and forecasting. I was more interested in understanding things like periodicities in a time series when it came to my academic work. And the strategy to deal with knowledge gaps is that if you're lucky, and in many cases you are, the notebook authors already kind of explain some of the background to the tools that they're using, and they give you some, references or links that you can follow up. There are certain books in general about kind of machine learning and data science that are pretty comprehensive and that have a lot of information. And if there's still something that I'm not sure about, I just Google it, and I usually find it in the forums, right? I find it either in like the Hugging Face forum if it's specifically about NLP, or maybe in the Fast AI forum or somewhere. So this would be kind of my step. Sometimes you find things like on Stack Overflow, like that happens to many of us, and then there's references there, and then you can kind of follow up. But what I found is that because notebooks are kind of running on the Kaggle platform in itself, they have to be able to run from top to bottom, and so you have to include all the data preparation and everything in your analysis. So this is a great way in which you have great examples for reproducible analysis that you can follow. And I hope that answers your question. All right, next one. For a newbie to data science, how do you find a notebook that's easy to understand so you can start your data science journey with Kaggle? You can do that through notebooks, you often it is the starter competitions that we looked at, like Titanic or House Prices or Amnes that you want to start with, because they often contain notebooks that show somebody else's first steps into the field, and you can follow those. And something that I also want you to be aware of is that Kaggle has these courses under Kaggle Learn, and they are pretty comprehensive too. So they start almost from scratch. They start with intro to programming. You're getting started with Python. They start with an intro to machine learning. Pandas, Python Pandas is an important tool that you're using a lot. Intermediate machine learning, handling missing values, and so on, data visualization. So there's a lot here. SQL, if you're working in industry, SQL is very important. So there's a lot of things here that you can kind of use to get a boost as to what you're doing. And then it's a lot. So if you go to Titanic, if you go to the notebooks, to the code, and because Titanic has been the longest running competition, there's some kind of there's a number of notebooks with crazy number of upvotes. To introduce introduction to ensembling, stacking, Titanic tutorial, and you can start with some of these, and they will be geared towards more narration and more exploration as to why certain tools are important. And many of them, they don't assume a lot of prior knowledge. So the starter competitions, tutorials, the Kaggle Learn, that's where I would start. All right, let's bring back the questions. Somebody asked about mobile games. I don't know about mobile games. I'm afraid I can't answer these questions. What would you say might be a good tool set as you enter into data science? So stuff that you gotta know. Yeah, I think you can pick up a lot of these things in the Kaggle Learn courses, but it also depends on what exactly you're working on and what your kind of what the scope of either your kind of, if you're doing it on the side, what kind of interests you. If you're interested in a specific job posting, then what is the scope of that. And there's this difference again between data analytics, data science, machine learning engineering, machine learning operations engineers, and so they have different portfolios that they would be aiming for. The kind of the base level of the things that you want to start out with are data science languages like Python. So Python is the most popular one. I still enjoy using R because it has great capabilities for tabular analysis and for data visualization, and has growing capabilities for neural networks as well. But I do acknowledge that Python is kind of more advanced in some of these aspects, and I'm using both regularly. So at work, I'm using Python and R. So you need a programming language like that, Python and R, to get started. You need some experience with data, right? This is what I always recommend. You want to get some kind of minimal requirements up there so that you can work with a data set, but then you want to get your hands dirty with data as soon as possible, just to work on a specific data set on a particular problem and start doing applied work, because then you'll learn about all these challenges, about all these potential pitfalls. You learn about data cleaning, about missing data. You learn about data that might need to be reshaped and transformed, and you learn about how to choose a tool that can answer a particular data problem. So stuff you want to know about these programming languages. You want to know about the fundamentals of machine learning. And I always recommend the scikit-learn tutorials because they are pretty comprehensive and I think underrated, and they kind of lead you through some of the basics of machine learning. And then it depends what you want to do, right? If you want to do a lot of deep learning, then I really like the Fast AI course. I think Fast AI and Jeremy Howard do a great job in kind of explaining neural networks from the ground up. If you're doing NLP, I like the Hugging Face course. So you want to start with a kind of a relatively small general foundation before you kind of look at your first data set, but then look at your first data set within, a week or so, because you wanna work with data as soon as possible. All right. Yes, so Buffy the Vampire Slayer, thank you, Amitha. That makes me feel less old. I do appreciate it. For Kaggle competitions, there's any registration charges? No, there's not. You can join any competition for free. You don't need to pay any money. You can win money, in fact, but in order to win money, you need to invest the most precious resource that there is, which is time. Right? Usually, in order to make progress and learn something from a competition in the most efficient way, what I would recommend is to spend at least an hour a day on it. Or let's say about an hour a day, right? It runs over 3 months. You can maybe, take a week off here or there are kind of days that are busier than others. But for me, the kind of secret to successful learning is consistency, right? And a Kaggle competition is about a specific problem. And if you're chipping away at a specific problem at a rate of about an hour or maybe half an hour a day consistently, then I can guarantee you that you'll make progress, because you're going through the experiments, you're going through the iterations, you're building your own stuff, you start kind of modifying other people's code, and you will definitely learn something. I cannot guarantee that you will win prize money, of course, but when it comes to the prize money, what makes the difference is often creativity and familiarity with the data set. So the better you know the competition data, the more you've experimented with it, the higher your chances are. But there's no registration charges. You have to accept the competition rules, which only kind of limit you from things that would be cheating anyway. So, and if you're learning, there is no point in cheating, because you would just be cheating yourself. Where does the prize money come from? I guess how the prize is being paid. Well, the prize money usually comes from the sponsors. So each competition has a sponsor. Sometimes the sponsor is just Kaggle when it comes to the analytics competition for the notebooks that I showed you, for instance. But in many cases, Kaggle works together with a company or an institution. Like for the gravitational waves, the prize money would come from these scientific institutes that do the research. And how the price is being paid? Well, through money transfer. Usually there is, if you're in the prize money, then you don't have to worry about that, right? Kaggle will contact you, the sponsors will contact you, there will be a call where you're all together and where you explain your solution, and then they will pay you. How not to get overwhelmed with the notebooks in a competition? Go through them step by step. Like, you have 3 months. Start with the most popular ones, and then start with some that might cover some aspects that you haven't read about yet, right? But like, if you only read one notebook a day, even if you just kind of skim through it, then you have about 100 days roughly to look at 100 notebooks, which is definitely more than enough. Is the book on R that you mentioned beginner friendly? Yes, it's very beginner friendly. It kind of takes you through the R tidyverse, which is a specific dialect of R, which I like very much, because it's very close to the way that I think about data in my head when it comes to manipulating tables and reshaping tables. But I definitely recommend it. R for Data Science by Hadley Wickham. The relevance of Kaggle versus Hugging Face. Well, Hugging Face is all NLP. Right. I mean, now there's like vision transformers and so on as well, and you have a kind of an active Discord and an active forum. But Kaggle is like the place where you find kind of many more interesting problems from other areas, and people with different backgrounds as well. So you can use some of your Hugging Face skills on Kaggle, definitely, and vice versa. Yeah, you might build a model or kind of train a specific model that you then can publish on Hugging Face. I think both are great avenues for learning, and Kaggle has this kind of aspect of having specific competitions, specific data sets, and a kind of slightly different community. that you can work with, but I like both of them. What advice would you give to someone just starting out with Kaggle for a father of 4-year-old and full-time employed? Specifically about dedicating time. Yeah, you don't have a lot of time in your life for this. To spend a little bit of time every day, and consistency is important. And even if it's just 15, 20 minutes every day, it's going to be not always easy to find time for this, but pick a specific problem that you're interested in, either specific data set or specific competitions or something, and then spend even just a little bit of time, but do it every day or nearly every day. And just focus on, taking a small step every day. And then over time, this will accumulate. So I think, consistency is the important thing. And even if it's just a little bit of time, you will learn something new. Is there a competition? We're getting close to time, so just tell me at some point. I'm trying to answer as many as possible. Is there a specific competition ladder on previous competitions? That's from beginner to advanced data sets. So not really. There's the starter competitions like Titanic or House Prizes or the digit recognizer for MNIST. And if you want to start from kind of zero, close to zero, then I would start with those. And then there's some competitions that are much more complex than others, and some that are easier, but they're not being kind of grouped together or anything, because people have different backgrounds. I think once you've done the starter competitions and have gained some insights into how the Kaggle platform works, I would recommend to pick a competition based on what interests you. And then if you find that the tools that you used are being too complex, then you can look for similar competitions in Kaggle's past that might be related to that one. And sometimes people mention in the discussion forums which these are. How to learn EDA? Yes. Well, you can check out my hidden gems. You can check out my notebooks. You can also check out the R for Data Science book that we just talked about like a few minutes ago. Hadley has some great insights into how to build plots and how to explore data. But it's practice. And maybe some of my notebooks could be helpful for you. Do hiring managers give importance to Kaggle notebooks if added to the resume? I don't know about that. I think it's much more important that you can use your Kaggle experience to answer interview problems or answer interview questions, solve interview problems, solve take-home tasks or something like this. And I would add your Kaggle profile link or so. You can definitely add that to the resume, then I can check it out. Begin doing, don't you think it's better to begin doing some tasks within the domain knowledge? Yeah, sure, you can do that. Like if you can already have some domain knowledge, you can pick something that's related and then start from there. But sometimes it's interesting just to jump into something completely new, right? And try to see, how much you can learn there. Like it's easier if you already have the domain knowledge, but the Kaggle community is pretty good in a competition to have you catch up pretty quickly. And final question, R or Python, what's your weapon of choice? For tabular data, it's definitely R. I'm going to commit to that because the tidyverse and ggplot2 in my case are such great tools. For anything kind of deep learning related at the moment, it's Python. And but all these things are in flux. But as so often, the answer is it depends. All right, I try to answer all of them. And I think we're at time. Thank you for having me. Bye-bye.